Welcome everybody, how are you? Today we are going to talk about the first lesson of trigonometry. Lesson 1, directed angle. We have studied the angle. The angle is the union of two rays with a common starting point. Look at this figure. If the ray AB and BC are two rays with a common starting point P, then the ray BA union the ray BC equal angle ABC, ABC or CBA or angle B, and the two rays BA and BC are called sides of the angle, and the point P is the vertex of the angle. Okay, as we know, ordering sides of the angle is not important. It's not important about order. We can say ABC or CBA. In this lesson, we will study a new concept which is called direct angle and some related subjects. Okay, what about direct angle? Look at with me. Direct angle. If we took into account an order of the angle in size, such that one of them is the unnatural side and the other is the terminal side, then the angle is right in an ordered pair, whose first projection is the initial side and the second projection is the terminal side. The angle in this case is called directed angle. It's agreed to draw an arrow between its two sides comes out of the initial side and to the terminal side. Look at with me. If ray OA and OB are two sides of the angles whose vertex is O, then the ordered pair OA and OB represents the directed angle AOB, whose initial side is OA and terminal side OB. Look at here, OA initial side, we called it initial side. OB terminal side, because this row coming from OA to OB. Okay, look at this. Look at this arrow coming from OA to OB, so OA will be initial side. Okay, initial side. Got another figure here. This arrow coming from OB to OA, so OB will be initial side, and OA terminal side. So we must look at the direction about the arrow coming from OB, so OB will be initial side. Coming from OA, so OA will be initial side. It's easy for you, okay? And OB here will be terminal side. And another figure of this angle AOB, direct about the order OP and OA. You write the first projection OB, so OB will be terminal side or initial side. Okay, in this figure OB will be initial side and OA terminal side. So the first will be, again look at here, OA and OB. We beginning from OB, so OB is initial side. Coming to OA, the arrow coming from OB to OA, so OA will be terminal side. So this order OA and OB not equal to order OB and OA. Directed angle AOB not equal to directed angle BOA. Okay, we can't repair to write O on anything or replacing letters. We must write the first projection OA and OB. This angle will be O is the vertex, so we can write AOB here. Okay, and the second projection OB and OA we can write BOA. Okay, BOA angle, directed angle this directed angle. Again, OA and OP, we can say it AOP directed angle. And the second projection, here OA, first projection OB. So this order we can find or can say directed angle BOA. It's easy for you. You must look at the first and say AOB. Okay, and this order BOA. Definition of the directed angle. The directed angle is an ordered pair of two rays called the sides of the angle with a common starting point called the vertex. Again, the directed angle is an ordered pair of two rays called the sides of the angle with a common starting point called the vertex. Check your understanding. Look at with me here. Look at this ray coming from ED to EA. So ED, we will say it's initial side. ED initial side. EF will be terminal side, terminal side, terminal side. Okay, so this directed angle will be DEF. DEF. We write here DEF. It's easy for you. Question number 2. Look at the ray coming from OX to OY. So OX will be initial side, initial side. OY will be terminal side, terminal side, terminal side. OX initial side, initial side, initial side, initial side. Okay, initial side, initial side. OA, OY will be terminal side, terminal side. Positive and negative. Look at what about positive and negative measuring of directed angle. Look at the direction. If the direction of the rotation from initial side to terminal side is anti-clock twice, anti-clock twice. Positive, anti-clock. Anti-clock, we know clock lifting from or drawing from left to right, clock. Okay, so direction anti-clock, the sign will be positive. anti-clock, ركز معايا. anti-clock, anti-clock twice, anti-clock twice, anti-clock twice. But negative, if the direction from initial side to terminal side with clock, clock twice, it will be negative. The direction of the rotation from initial side to the terminal side is clock twice, will be negative. Look at here. Look at here. This coordinate, this directed angle A, O, B, and this ray coming from OA to AB. OA initial side, initial side, and OB terminal side. Coming from OA to OB. This direction anti-clockwise, anti-clockwise. So the sign will be positive. The sign will be positive. Okay. But if the direction about direct angle coming with clockwise, the sign will be negative. It's easy for you. It's terminal side, terminal side, and this initial side. you see it coming from initial side to terminal side. The direction with the clock, clockwise will be negative, but this anti-clockwise. We know the clock direction about this long and small direction in this rotate. Okay, so if the direction with a clockwise, the sign will be negative, and the direction moving anti-clockwise, the sign will be positive. Look at this angle. This ray coming from OA to OB, so OA will be initial side, and OB terminal side. The direction is positive, but the direction coming from OA to OB, this will be negative because it's coming with a clockwise. But this from OA, this direction from OA to AB, anti-clockwise, so the sign will be positive. The absolute value of positive measure of the directed angle plus the absolute value of negative measure of the same direct angle equals 360. It's easy. Again, each direct angle has to measure one of them, or one is positive and the other is negative, such that the sum of the absolute value of two measure of equal 360. Okay, the measure of angle AOP and O or POA, positive and negative angle, absolute value of them equals 360. So that if the positive measure of directed angle equals theta, then the negative measure of the same directed angle equals theta subtract 360. Again, if the positive measure of directed angle equals theta, then the negative measure of the same direct angle equals theta subtract 360. For example, the negative measure of the directed angle of measure 210 equal 210 subtract 360 equal negative 150. Number 2, if the negative measure of the directed angle equal negative theta, then the positive measure of the same angle negative theta plus 360. For example, the positive measure of the directed angle measure negative 120 equal negative 120 plus 360 equal 240. Again, if you want to find the positive measure, you must add 360, and if you want to find the negative measure, we can find the result by add negative 360. Okay, it's easy for you. Again, we will solve it. The question to understood this question. Look at this. Pay attention with me. Number 1, the positive measure of the directed angle whose measure is negative 170 equal space. Again, the positive, he want to find the positive measure, so we can find it by add 360. So we can find negative 170 plus 360. Okay, we can find the measure because he want to find the positive measure. The positive measure we can find by add 360. So the result will be 0 subtract 0 equals 0, 6 subtract 7 we can't do, so we will pour 1 from 2, 3 will be 2, 16 subtract 7 equal 9, 2 subtract 1 equal 1. This measure 190. Okay, question number 2. The negative measure of the directed angle whose measure 320. He want to find the negative measure. So we will add negative 360 to this angle. So the result will be negative because 360 more than 320. 0 subtract 0 equals 0, 6 subtract 2 equal 4. The result will be negative 40. Negative 40. Question example 1. Example number 1. Find the measure of directed angle theta in each of the following figures. Look at figure 1. This direction, look at this direction coming from this side to this side, and the ray coming with twice clock or clockwise. The direction is clockwise. The direction is clockwise. You know this direction coming from this side to this side. I will solve it here. Look at here to understand this question. You must know the direction. Direction coming from this ray to this ray, or this side to this right, and this angle is 42. The direction is clockwise, so we can find the measure of directed will be 42 subtract 360 because the direction is clockwise. We can find the result. The result will be negative 10, and this 5 will be 5. 10 minus 2 equal 8. 5 minus 2 equal 1. 5 minus 4 equal 1. We write 3 here. So the result will be negative 318. And another, look at another question. This figure we draw it here. This angle 53 degree and direction anti-clockwise. Okay, this anti-clockwise, so the measure will be 53 plus 360. 53 direction will be negative, and this direction anti-clockwise, so we can write negative 53 plus 360. Okay, he solved this question in your book. Look at the solution. He solved it here. Okay, this is the steps about solving question. Okay, we solve question number 2. The rotation direction is anti-clockwise. The measure of the angle is positive, so theta will be negative 53 plus 360. The result will be 307 degree. Okay, try to solve number 1. I will draw it here to understand it. Okay, and you must try it after me. This direction, drawing this direction. Look at this direction, anti-clockwise, and this angle 64 will drawing clockwise, negative 64 will adding plus 360. This direction inverse the first direction. So the second direction inverse of first direction. First direction anti-clockwise, 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 and this direction will be clockwise, 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 clockwise. So the sign will be negative, and this direction anti-clockwise we will write plus 360. So we can find the measure. 10, this is 5. 10 minus 4 equals 6. 5 minus 6, we can find it, 1. 15 minus 6 equals 9. And we write 2 here. So the measure will be 296 degree. Okay. Another question. Look at with me here. This figure is directed angle. This direction clockwise with clockwise, okay, and this will be inverse. Look at this direction with clockwise, and this anti-clockwise, anti-clockwise. So it will be 135 because this will be negative. It will be negative because it's no, sorry, I will inverse it here. It draws this and this inverse, okay, this inverse, so it will be positive. Okay, again this direction is clockwise, so this direction will be inverse about this direction, anti-clockwise, and this because this clock drawing direction about clock, this clock here. So this direction with clockwise, and this direction will be inverse about this. This will be anti-clockwise, so we can find here positive 135, and this direction with clockwise, so we will put negative 360. It's easy for you. Again, we must write angle, and you must determine the sign about this angle. This direction with or inverse of clock. It's inverse of clock, okay. This anti-clockwise, so we will write positive about 135, and you find the direction with clockwise, you must put negative 360 here. So you can find the result. It will be 10, this 5 subtract 3 equal 2, 3 subtract 1 equal 2. The result will be negative 225. Okay, because this direction was clockwise. It's easy for you, understood? You can stop this video and prepare. Okay, I will solve question. This question, okay, here we have angle 30 degree and 33 minutes, and this direction anti-clockwise, so we can write negative or positive. This will be negative because it's coming with clockwise, negative 90 degree 33 minutes, and you find this sign will be positive, so we can put here 360 equal. We can find the result by here by your calculator or your your hand, okay, your mind, okay. 360, we can write 359 degree, 60 minutes, subtract 90 degree, 33 minutes. 10 minus 3 equals 7, 5 minus 3 equals 2, 9 minus 0 equals 9, 15 minus 9 equals 6, 2. This will be a result. It's okay for you? Okay, another question. Look at this standard position of directed angle. A directed angle is in the standard position if the following conditions are satisfied. Satisfied, okay. Condition 1 and condition 2. Number 1, its initial side lies on the positive direction of the x-axis. Its vertex is the original point of an original coordinate plane. Again, a direct angle is the standard position if the following two conditions are satisfied. Number 1, its initial side lies on the positive direction of the x-axis. Number 2, its vertex is original. Its vertex is the original point of an original coordinate plane. Such as at this drawing. Look at here, OA to OP. OA initial side, OP terminal side. We come from OA to OB, and OA lies on x-axis. Number 2, OA, its initial side, coming to OP terminal side. So this angle XOP, direct angle AOB, and this OA initial side to OP terminal side. All the following directed angles are not standard position here, but all the following angles in the standard position because they fulfill these two conditions. They verify two conditions. Okay, we have two conditions here. Okay, all the following directed angles are not in the standard position because the initial side doesn't on OX. Look at here, AOP, directed angle. It's not directed angle. Why? It's directed angle, but it's not in the standard position because OA not lies on OX. So we must draw the initial sides in OX. But in this figure, this coordinate directed angle AOP is not in the standard position, and this angle directed angle AOP is not standard position because OA doesn't lie on OX, and this directed angle AOP is not in the standard position because OA doesn't lies on OX. Okay, so all the following directed angle are not in the standard position because the initial side doesn't lie on OX. Look at here, directed angle in the opposite figure is not the standard position. Why? Because its vertex C is not original point O. It must put here, we must put this angle, this vertex in O. Example number 2, you solve it. Look at here. Which of the following order pairs represent a direct angle in the standard position? Number 1, OA and OD. look here with me. It's clear with you? Okay. OA and OD, where OA and OD. Okay, we can represent the rectangle AOD. It's a standard position. Okay, it's a standard position because OA lies on OX. Question number 2, CA and CB. CA and CB. No. Look here again. There is CA and CB. We can say ACB represents the directed angle. C here again, CA and CB, we can represent the directed angle will be ACB, but not its standard position because its vertex C is not the original. Look at here, ACB. You look here, it's clear with you? ACB. This point C, the vertex C must be put here, put in O. So the represent direction angle ACB, but not its the standard position because its vertex C is not the original. Because its vertex C is not the original. So the angle ACB, it's not standard position. Okay, not standard position. Question number 3, OD and OF. This angle, that angle will be DOF. DOF here, DOF represents the direction angle DOF, but not its standard position because its initial side OD doesn't lies on OX. Again, represents direction angle DOF in standard position because not its standard position. It's not standard position DOF. Why? Because OD, its initial side doesn't lies on X, so OD must be lies on OX. So directed angle DOF, it's not standard position. Why? Because its initial side OD doesn't lies on OX. Okay. Question number 4, OA and OE. We will standard position or not? AOE. Where AOE. Okay. AOE and direct angle because initial side lies on OX. It's a standard position. Because OA initial side lies on OX and its vertex O is the original point. Okay, try to solve which of the following order pairs represent directed angle in its standard position and why. OA and OB. Look at here, OA and OB. This angle, that angle will be AOB. AOP, its standard position because OA lies on OX and O is the original point. Okay, so number 1 is standard position. Question number 2, EA and EF. The angle will be AEF. Directed angle AEF. AEF. It's not standard position. Why? Because E doesn't lies on O. Because E doesn't O original point. So EF, directed angle AEF, not direct or not position, not standard position. Again, angle AEF, not standard position. Why? Because the vertex E doesn't original point. Question number 3, OC and OA. The ray OC and OA, we can represent it COA. COA, direct angle. COA, look at here, COA. COA, not standard position, because CO, initial side, doesn't lie on OX. So the angle COA doesn't standard position, because the initial side OC doesn't lie on OX. Question number 4, the order of the ray OP and the ray OD. We can represent this order to be directed angle BOD. BOD, it's not standard position, because initial side OP doesn't lie on OX. So the direct angle BOD doesn't standard position. Look at here, equivalent angles. If we notice the direct angle in standard position in the following figures. Look at figure 1, 2 and 3 and 4 and 5. We can find equivalent or equivalent angles. How we can find it? By 360 or twice 360 to these angles. The angle will be positive or negative. We will say the equation to solve it. Look at here. Example number 3. Here, determine, he asked us, determine two angle, one with positive measure and other with negative measure. Okay, having common terminal side 4, 100 degree. We can find an angle with positive measure 100 plus 360 equal 460 degree, and an angle with negative measure we will put negative 360 to 100. Okay, there are an infinite numbers of the other positive and negative measure of angles having common terminal side. Question number 2, an angle with positive measure, this angle negative 250, we will put plus 360, the result will be 110. An angle with negative measure, where question number 3, okay, again question number 3 here, an angle positive, we will put positive 360, it will be 110. An angle with negative measure, we will put negative 360 to this angle negative 250, so the result will be negative 610. Question or example number 4, determine the smallest positive measure for each of the angles whose measure are as follows. Number 1, the smallest positive measure equal negative 62 plus 360, it will be 298. The smallest positive measure, we will put 360 to this angle negative 225, so the result will be 135. Number 3, the smallest positive measure, about 530 degree, we will subtract 360, it will be 170. Number 4, negative 790, we will add 363 twice to find the positive. Okay, so if you want to find or determine the smallest positive of measure of angle, we will put about negative 62 plus or aid 360 degree. Number 2 plus 360 degree. Number 3 subtract 360 degree. Number 4 plus 360 degree 3 twice, so the result will be 290 degree. Try to solve. Number 1, determine a negative measure for h. You want to find a negative measure. It's easy. We will put about 72 negative 360. Okay, look at here. I will solve it here. Okay, number 1, 722 will put 360 negative 360 because he want to find a negative measure. We will write negative here 10, and this will be 5. 10 minus 2 equal 8. 5 minus 7. We can find the result. We borrow 1 from 3. 3 will be 2. 6, 5 will be 15. Subtract 7 equal 8. And right here, this angle will be negative 288 degree. Okay, question number 2. 1150 subtract. We can write 3 multiply by 360 or 2. We can write 2 first. 360, it will be subtract 720, it will be 0. 3 11 subtract 3 equal 4, and we can find 430 subtract 360. So we must find in the first, subtract 3 twice of 360. Okay, if you find the result more than 360, you must subtract 360 from this angle. Okay, 0 13 subtract 6 equals 7. The result will be 70 degree. Okay, you want to find the negative, so the result 70 degree. I will subtract 360 again to find the negative. If you want to find the positive, you will write 70 degree, but he want to find the negative measure, so you will complete by subtract 360. The result will be negative 200, and it will be 0 here. 16 divided by 7 equal 9, 290 degree. This is a measure. Okay, question number 1 and question number 2. You must find the result by using calculator. You can find the result by using calculator. Subtract negative or negative 360 to get a negative. When this number or this result appear on your calculator, you stop. You will stop. Okay, it's very easy about your calculator to find subtract the result 360. Question number 2, determine the smallest positive measure of each of number 1. Negative 150 you will put plus 360. Question number 1. Negative 115 plus 360, it will be 10, and this will be 5. 10 subtract 5 equal 5. 5 minus 3 minus 1 equal 4. 3 minus 1 equal 2. The result will be 245. Question number 2. 405 subtract 360. 5 minus 0 equal 5. It will be 10. This 10 minus 6 equal 4. 3 minus 3 equal 0. The result will be 45 degree. It's okay. Angle position in the horizontal coordinate plate. angle position in the original coordinate plane. We know that the original coordinate plane is divided into quadrant 4 quadrants as these point figures: first, second, third, fourth. The position of the directed angle is determined by its terminal side when it is in its standard position. Okay. If we draw the directed angle AOP in the standard position of positive measure theta, then the terminal side OP lies in a quadrant as following. Here, first, because theta more than 0, less than 90 degree, and OP in the second quadrant, OP third quadrant, OP here in the fourth quadrant. Remark: if the terminal side lies on one of the two axes on the angle is called quadrant angle. Right here in your notebook, quadrant angle, such that 0 degree, 90 degree, 180 degree, 270, 360 degree are quadrant angles. Quadrant angles. Okay? Quadrant angles. You must keep in your mind this word: quadrantal angle, quadrantal angle, quadrantal angle, quadrantal angle. Example number 5, and this solution he solved it here. Okay, 213 lies on third quadrant. I will solve it in this notebook. Okay, look at with me here. I will solve it here. Okay, to understood. It's easy for you. You must draw when you want to solve any question. You must draw the coordinate here, and the right here 0, 90 degree, and here 180, 270. This first, second, third, fourth. Okay, 213 lies between 180 and 270. The measure here 230 degree lies on third degree, and 132 here lies on the second quadrant. Negative 310, we must solve it. Look at here, negative 310. We must find the smallest positive angle by 360 to this measure. The result will be 50 degree. So 50 degree lies here in the fourth. In this is the quadrant, first quadrant. Here 50 degree. It will be negative 310 degree. Convert by 360. It will be 50. Okay, so you must find the measure by plus or 360 to the measure. Question number 4. Negative 12. Negative 12 lies here in the fourth. Negative 12 here. You can find by your mind here negative 12 in the fourth, or you can find negative 12 by plus 360. 10 subtract 2 equal 8. 5 subtract 5 subtract 1 equal 4. 3. It lies here 348. So negative 12 lies in the fourth. Question number 5. 270. Here it's a quadrant angle, 270 degree. We called it quadrantal angle. You know it? Quadrantal angle. Quadrantal angle. Quadrantal angle 270 degree. And Question number 6. 964. We will subtract 270, 360, and 360. Twice of 360. The result will be 4. 16 minus 7 equal 9. 8 minus 2 equal 6. And we can subtract. No, sorry, I can write 720. Sorry, I will solve it again. 720 is twice of 360. 4 subtract 0 equal 4. 6 subtract 2 equal 4. 9 subtract 7 equal 2. The result will be 244. Lies here, where? Lies here, in the third. Okay. 244 here. 244 is the third. So this angle 964 lies on the third quadrant. The third quadrant here, because 964 lies between 180 and 270. It lies between them. Question number 7. Negative 1070. Subtract or plus. We will plus here 100 or 3 twice 300, 3 twice of 360. 3 multiply 360. Negative 107 plus 3 multiply 360. 3 times 360. 3 times 0 equals 0. 3 times 6 equals 18. 8 and the care of 1. 3 times 3 equals 9 plus 1 equals 10. Okay. We will find the result. The result will be 10 degree. 10 degree lies on first. So this angle negative 1070 here. Negative 170 degree lies here. Okay, we solve it here. Let's step out the solution. You can solve it in your homework. Okay, it's easy for you. And we finished with questions. You must study hard this question, okay? And I will complete all questions in another video. Thank you for your students. Goodbye.